Welcome to Mastering Machines, where we discover tomorrow's reality.
This past week, Meta released a text-to-video generator called MovieGen. The quality of the video generations look great. Also, MovieGen could be a peek into the future on how Meta will use AI generators to kind of complement the content that they have on their platforms. Let's take a look at what's under the hood of MovieGen. So MovieGen isn't just one model, but it's a group of specialized AI models that work in harmony with each other. So there's first the MovieGen video model, which is basically the main star of the show here. It's a 30 billion parameter transformer-based model that generates high definition videos up to a maximum of 16 seconds long at 16 frames per second. And I was looking in the paper and it uses this interesting trick called flow matching, which I'll talk about in a little bit. Then there's the personalized MovieGen video model, and this model adds the ability to generate videos on specific individuals, and you can base it off of a single reference image. And of course, if you include more referencing images of that particular person or thing, the video is going to be way better. So I definitely recommend putting in more reference images, like 3 to 5. Then there's MovieGen Edit, a model that allows for precise instruction-based video editing without the need of any supervised video editing data. So you'll be able to get directions on how you want to have it, laid out, or how you want to have that video constructed. And the last model in this group is the MovieGen audio model, which is a 13 billion parameter model that generates 48 kilohertz of high quality sound effects and music that's also synchronized with this video. So not only is it generating video, it's also generating the audio that will go along with it that complements it well. I mentioned it earlier, but I want to spend some more time on it, and that's the feature of flow matching. Flow matching is an approach that generates a sample by iteratively changing a sample from a prior distribution. During training, it learns to predict the velocity that moves a noisy sample towards the target video. So it's literally looking at all the different aspects of the video and matching up audio that would align with it best, so you have the best possible target video that you wanted generated. And let's take a look at some of the other features that work in tandem with flow matching as well. One of those features is TAE, and that is an abbreviation for temporal auto encoder. And this basically handles the massive amount of data in videos efficiently. MovieGen uses a TAE to compress videos in both space and time, and then it compresses the input 8 times across each spatial temporal dimension, allowing the model to generate longer and higher resolution videos. And this is built on Llama 3 inspired architecture, while also being trained in multiple stages. They started with text to image generation, then joint text to image and text to video generation, then first at 256px resolution and then at 768px resolution. And this works in tandem with the feature in the paper that they talk about, which is called Spatial Upsampler, which is a separate 7 billion parameter model that upscales the 768px videos that I was talking about just a second ago to full 1080p HD resolution. Speaking of the training of MovieGen, the pre-training data is a massive 100 million data set, video text pairs, and 1 billion image text pairs. Also, the Meta team implemented data curation into the training, which allows sophisticated data curation pipeline to ensure high quality training data is getting into the model, and it's filtering it for visual quality, motion, and content diversity. So whatever data is being brought into the model is the top quality data. They also actually trained it on captioning as well. They used Llama 3 video to generate detailed captions for the video clips, including camera motion information. So you're getting everything that's based around the video and getting the captions right in there. And the last aspect of the training data is the supervised fine tuning. After pre-training, the model undergoes supervised fine tuning on a smaller set of high quality videos to improve motion and aesthetic quality. And here's a lineup of what things the MovieGen model can actually do. We talked about it earlier, but it can do text to video generation. It can also do video personalization, precise video editing, audio generation, and even multimodal generation. So it can, when we were talking about earlier with the training, it can handle various aspect ratios, resolutions, and video lengths once it gets to that point where it's generating more video lengths past that 16-second limit mark. And as I said, the current limit is 16 seconds. So that's definitely one of the limiting factors of this model. But once again, this video model really allows for a lot of specific video editing instructions because of how it was trained. And I think that that's one of the most unique things about this model, and what I've read about it in the paper is that it is trained on the spatial awareness of different videos and how they kind of look and their aesthetic, so you can kind of guide it in whatever way that you would like, and it would actually be able to handle that aesthetic or control. MovieGen is one of the bigger steps in the text to video generation revolution that's happening right now, and it's only going to get better from this point, right? We've seen it with the partnership with Runway and Lionsgate, and we're going to see more of these aspects of the movie industry and TV industry get kind of upended by text to image generators. Will it lead to a renaissance of storytelling because everybody will have similar tools, or will it lead to even more of an overload of content than what we've even been getting from the last 1 year or 2 years with all of the video generated content that's coming from TikTok and IG? Let me know in the comments. Remember, master machines discover tomorrow's reality.